Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. What we're going to be doing now is filtering traffic with IP tables. Yes, we are. And the one person I know of who can help us with that is here as well, and that's Don Pizzette. Don, good to see you.
Hey, glad to be here, Zach. And we're delving into the world of IP tables, which was, up until recently, one of the more popular host-based firewalls available on the Linux operating system. Many distros have switched over to Firewall D at this point, but IP tables is still readily used out there. And so in this episode, we're going to learn a little bit about how IP tables works, how we can configure it, how we can install it if we need it, even reverting a system back if we want to. So we'll get a chance to see all of that right here in this episode.
So, Don, how do we know if we're running IP tables?
The easiest way, it's just like Firewall D, is to look for the service. It can be a little bit tricky because what's going on with Firewall D and IP tables, they're really just kind of front ends for the NetFilter service. So NetFilter is the actual firewall you're running, and that means that you might not be running IP tables, but the IP tables utilities might still be there, and that's a little bit tricky. So for example, let me take this one. I'm on a CentOS 7 box, so this would be just like Red Hat Enterprise Linux or CentOS in this case. And if I come in here and say, all right, do I have the IP tables command? You could run IP tables dash list. And, oh, shoot, I'm not an administrator. So I'm going to do a quick sudo -s to get admin privileges. And then I'll do IP tables dash list. All right. So I get a set of rules that come back. So it looks like I'm running IP tables, but in reality, I'm not. I just have the utilities. The IP tables utilities are installed by default because they work with NetFilter. And people might have scripts that depend on this. I'm actually running firewall CMD. If I do a firewall -cmd get zones, for example. So there it is. I see zones come back, and then I'm running it. If I were to do a systemctl status IP tables, I can see I'm not running IP tables versus a systemctl status firewall D. There I go, and I can see that I have an active and running Firewall D environment. So this is kind of an interesting thing, right? That you might have the IP tables utilities, but not actually have the service running or even installed. So I always recommend, if you're not sure which firewall you're using, use systemctl, look at the status of the services, and that'll clear it up real quick. In my case, I know that I'm running Firewall D. So it's going to be hard to film an episode on IP tables if I don't switch over to IP tables. And it's actually pretty easy. Because this is all built on top of NetFilter, the NetFilter service, that stays the same. So the underlying architecture really doesn't change. All I need to do is turn off Firewall D and turn on IP tables, okay? So the first thing I'm going to do is get IP tables installed. Now, there's two different packages for IP tables. So if I do like I don't need a sudo anymore since I'm admin, I'll do a yum list IP tables star. Okay, one package I can see is already installed for me. It's just called IP tables. All right, that's the IP tables utilities. And then there's another package called IP tables services, and that's the actual service. That's the IP tables firewall. And for me, it's an available package. It's not actually installed. So I'm going to do a yum install IP tables -services. I'll do a -y, so it'll just authorize it and install it. All right. Service is super small, so it's going to install really, really quick. I downloaded 52 kilobytes of data, so really tiny. Once it's there, I don't want to turn it on just yet. I've got to turn off Firewall D first. Now, I've got some choices. I could remove Firewall D, but I recommend you don't do that. And the reason is a lot of distros kind of expect it to be there, and you might choose to switch over to it in the future, so it's kind of easier to just leave it there. So what I'm going to do is systemctl stop Firewall D, and I'm going to turn it off. Now, what I used to do next is I used to do systemctl disable Firewall D, but I noticed in a few scenarios in a production environment that Firewall D might start up again. And if you disable it, that's telling the system don't start Firewall D when you reboot, but other services might actually trigger Firewall D to start again, and I don't want that. So instead of disabling it, I'm going to mask it. And by masking it, that tells the system to link it to /dev/null, And if anybody tries to start firewall D, we'll just send the request to /dev/null and not do it. So that's better than disabling it. The alternative would be uninstalling it, which again, I said I prefer not to do. I like to leave default stuff there if I can. Once that's done, then I can follow that up with systemctl -- enable, or sorry, just enable -- now IP tables. Okay, and that's going to turn on the IP table service, and now I'm actually running IP tables. I've shut off firewall D, and IP tables is up. If I'm doing IPv6 as well, I would need to add IP table 6, or sorry, IP6 tables to get that one going. I'm not doing IPv6, so I'm going to leave that off, but that would be the extra step there to get that one up and going. But at this point, I've converted over. So it was super easy. It's not a hard thing to flip from firewall D to IP tables if you need it.
Where do we get started configuring the firewall?
It depends on what kind of configuration we want to do. With IP tables, the main way we interact with it is through the command line. We can use the IP tables command, that service that I pulled up a moment ago, to interact with it and create rules. So, for example, I showed you guys IP tables -- list. All right. And when you run that, that just gives you a output that shows the rules that are in place. And it's kind of interesting as you look down the list, you'll see some of the different things that are listed here. I've got my input chain, my forward chain, my output chain, and it's kind of listing what's allowed to pass through those. This output looks different than it did before. When I ran it at the beginning of the show, let's see if I can scroll back and find that. If I scroll all the way back to where I ran that, the output was a lot messier. Okay, see all this? And that's because it's showing all sorts of different zones. These are actually the firewall D zones that were present. And if you look, like if you watched our firewall D episode, I had a zone called public, and I added FTP and HTTP to it. So looking here, I should be able to find that public zone in here somewhere. I'd probably faster to grep it. And in there, actually it's right here, right in front of me. Here's the chain in public allow, and there's SSH, FTP, HTTP. That's from the previous episode. So IP tables was actually able to see that, but the config is not what it expected. Now that I've turned off firewall D, those zones disappear. And so now the config is what IP tables expected. And that's why it's nice and neat, and I can read through it. And looking at it, I no longer see FTP and SSH and HTTP. I do see SSH because that was enabled by default. But the rules that I had written in that other episode are gone because the public zone is gone. And you could go a step further and say -- list - rules. And this gives you the configuration in a different form. When we write the config, in the config file, it looks different. On the command line, we enter it in one format. And then in the config files, it goes in a different format. So here it's showing me the format as it would be written on the disk. And I can see, looking down the list, no sign of FTP or HTTP in here, because that was all part of my firewall D config. So while they both use NetFilter, the rules aren't directly compatible. So when we turn one off, we lose the rules, and then we have to rewrite them under the new program.
How did the chains work together, Don?
So the chains. I kind of just glossed over those real quick, didn't I? You'll see here we've got chain input, forward, and output. When you write rules in IP tables, there's 3 different places they can take effect, right? The first is input. We're catching packets as they enter our network interface. So this is right when we receive the packet. Do we go ahead and block it or allow it or what? Then there's output. This is when it's leaving our computer, our outbound traffic. And do we want to block that? Outbound on a workstation usually means you going out somewhere, right? But there is a middle one called forward, and forward's not really used on a workstation. But if you have a server configured as a router or a firewall, you might have traffic come in one interface and go out another interface. Well, forward is in between. The traffic comes in interface 1, it's then forwarded to interface 2, and then it goes out interface 2. So you can filter traffic at any step along that journey, in, forwarding, and out. Now, for performance, you're usually better off filtering traffic on the way in than on the way out. And that's because if something comes in, you have to decode the packet, interpret it, then it's got to get forwarded, so it runs against the routing table, it gets sent to the other interface, and then it goes to send it out, and it throws it away. Well, you just wasted all that processor time handling a packet that you just ended up throwing away. So it's usually better to filter traffic on the way in. Outbound is usually when we're just trying to restrict ourselves, trying to stop applications from doing things they shouldn't do. Most people just have a simple output like mine. See how I don't really have any rules in here? Which just says, yeah, whatever, anything can go out. I'm not filtering. I'm allowed to go and do whatever I want. I don't want other people coming into my system. And so we're much more strict here on the input. But that's what those chains are. And they'll usually be written like this, where you have a bunch of accepts. This is what's allowed to come in. And then one great big statement here that says reject all, right? So if something matches an accept rule, it's going to be allowed in. And if it doesn't match any of those rules, it'll hit this reject all and get thrown away. So I'm saying that only these 4 things right now are allowed to come into my system. And it's pings, looks like established session. So if I sent something out, people are allowed to reply to me. We've got, oh, actually, we got a wide open rule here, accept all, anywhere to anywhere. That's not good. So that's basically opening up that whole rule. So I probably need to change that. And then after that, we're allowing TCP for SSH, and we've got reject for everything else. So those are kind of the rules that are in place. And that's how those usually kind of function. But the chains all work together to create that flow of traffic through my system.
Well, how do the rules work?
All right, so the rules are based on 2 simple ideas, right? One, we have to identify traffic. So there's something that identifies it. And looking at these rules, you'll see things like DPT. That means destination port. If we see traffic where the destination port is SSH, right? That's an identifier. Or if the state is new, if this is a new incoming communication, or state established, that means I'm already talking to that person. There's got to be some kind of criteria. Maybe it's the source IP address or the destination IP address, the protocol. That's how we identify traffic. And then once we identify it, we have to take an action. And there's 3 main actions. Okay, so looking here, you can see accept, reject, and there's one more that's called drop. All right, accept means we allow it through. That's good. Reject means we block it and we tell the people that we blocked it. We say, nope, that's not allowed to come through. Drop means we just throw it away and we don't tell people about it. Like, we're just going to discard that. The problem with reject, if you're sending messages back to people and you're getting like denial of service, you'll get flooded not just with traffic coming in, but with you sending reject messages back out. So drops are a little more efficient. But drops are not as friendly on the network because whoever sent it and got blocked, they don't know they got blocked. And so they're waiting and waiting and they have to retransmit. And so you don't want that to happen to your legitimate users. You don't care about the attackers, right? But your regular users, you don't want them to have to wait inordinate amount of time to see that, they just typed in the wrong thing. So reject and accept are the 2 most commonly used, but drop is a 3rd one, right? So rules are made up of those 2 pieces, some kind of identifier, and then the action that you're going to take. And then it's which chain you put them in that influences whether this is incoming traffic or outgoing traffic. And when we have all that put in place, now we know exactly, what's going to happen with that traffic.
So then, my friend, how do we manage incoming traffic?
All right, so the easiest way is from the command line, we can use the iptables utility. So that utility lets us modify rules and add them in and kind of change them. If we want to filter that traffic, we need to have a good idea of how we identify that traffic, right? So the 2 pieces to a rule. One is identification. We've got to identify the traffic somehow. That might be by source IP address or destination IP address. It might be source port or destination port. It might be protocol. Like all of these are different things that we can identify traffic based on. So we need to figure out how we're going to identify it. And then we need to pick our action, right? Accept, reject, block, which one we're going to do. And when we have all that figured out in our heads, then we just sit down and we write it as a rule using the iptables command. So let me show you an example. Let's say that I want to have a web server and I'm going to be allowing HTTP traffic to come in, web traffic. All right, so how do I identify this? Well, source IP and source port could be anybody in the world, right? So I don't know those, I'll ignore them. Destination port, that's going to be port 80, right? And protocol, that's going to be TCP. So if I look for traffic on TCP port 80 that's coming into my system, then that's going to be web traffic. And I want to allow that or accept it to come in, right? So to write that rule, what we're going to do is say iptables -a, and -a is not accept. This is telling it what I want to analyze, right? So I need to point to a chain. And my chain in this case is going to be the input chain. So I'm analyzing incoming traffic, right? From there, I know the port, or protocol, right? So the protocol, if I do a -p, is TCP. So it's TCP port 80. So that's the start. And then the D port, --D port, that's destination port. The destination port for this traffic will be 80. And some protocols actually have a named identifier that you can use. Like I might be able to type HTTP here, But it's not like systemd where you have this whole directory of XML files you can look at and know what's supported. In this case, you have to look at iptables documentation. So for me, I've kind of just gotten in the habit of using numbers because the numbers always work. And if there is a named alias, it'll change it for you when it actually applies it. So we'll see that later. It actually does some really neat stuff. When this gets put in place, it optimizes it a couple of ways. Well, I'll highlight that in a moment. All right, so I know the traffic has a protocol of TCP and a destination port of 80, right? I don't really care about source IP, destination IP. I don't care about source port, so I can leave all that stuff off. But I do need to give it a action. And so I'm going to say -J and what action I want it to take. Drop, accept, reject. And in my case, I want to accept this traffic. So I'll go ahead and run that, and that's going to enter in my first rule. So it puts that in place, and now I've got that rule in. If I do a, let's see, iptables -- list, and take a look at what I've got here, I've got this new accept rule right here that's allowing traffic from anywhere to anywhere using TCP, destination port, HTTP. So there's my first entry. Now that rule was pretty simple. Let's go a little more complex. Let's say I want to allow SSH, but only from a particular IP. I don't want everybody to SSH in. I just want this one workstation. Maybe it's my workstation in my office. So I could come in and say iptables -A input, right? So it's still incoming traffic. -P, SSH uses TCP, so that's easy. -D port. And I know it uses port 22, but there is actually a named alias here, so I can just type SSH if I want, either way. And notice how with HTTP, see how it changed it from 80 to HTTP for me, so it'll set it on its own. And then I want to specify a particular IP. I'm being picky this time. So I'm going to do a -S for source, and the source is going to be 10.0.222.222. All right, so that's source IP. And then the action, I'll do -J accept, and that's going to allow that traffic to come in. So a much more granular rule here, being a little more specific. If I do iptables -- list, I can see that second rule. And see with HTTP, the source is anywhere, but not with SSH. It's very specific. This IP going in via SSH, that one's going to be accepted and allowed in. So once I've written those rules are now created, but they're created in RAM, right? If I were to reboot my system, or if I were to restart iptables, these rules are going to go away. And it's going to go back to the configuration that's written on disk. So once I've got my rules defined, I need to save them. And we can do that by using the iptables -save command, all right? Now, if you just run iptables -save by itself, it does something interesting. It shows you the configuration, right? And it even says commit and that it completed, but it doesn't actually write it to disk. What it's doing is it's writing to std out or standard out, right? Which is your screen. So it's showing me what that configuration would look like on disk. And so mine looks like this. I've got my input, forward, and output chains that are defined. And then on the input chain, I'm adding two rules, right? One rule, which is allowing TCP port 80 to come in, and then another rule that's allowing just one IP to get in there. And it's optimizing them a little bit for me. For example, when I approved that one IP to come in, I did the -S with the IP at the end of the command. See how it moved it to the beginning? And I didn't do a subnet mask on it. It added a /32. It's optimizing it to make it run the most efficient way possible inside of NetFilter. Okay, so those are the rules. That is the configuration that I need. Okay, but it's not actually saving it to disk. And I can verify that if you cat the /etc/sysconfig/iptables file, that's where the configuration is actually stored. And if I take a look at that, I see something very different. This is the default configuration that comes with CentOS right here. And looking down that list, I don't see any of my rules. So this was not updated to include my rules. But if you look, it says, this is a sample. You can edit it. It's got the commit command, just like I had when I ran iptables -save. In fact, iptables -save is designed where it's got comment marks on the lines that tell you it's working and it's completed, so that you can just redirect this output right to that file. So if I run iptables -save and then do a greater than sign, that says take the output and then send that over to /etc/sysconfig/iptables. And when you do that, that's going to save the configuration to disk. And now it's there. If you want to see it on screen at the same time, instead of using the greater than sign, you could pipe the output into the T command. And now you'll see it on screen and it gets written to disk at the same time. So now you kind of verify it. But that actually saves that configuration. iptables makes you do the extra step because if you put something in wrong, well, a lot of things can happen. But the worst thing is when you allow traffic you didn't intend to allow, right? So it's always double checking for stuff like that and making sure that you don't allow that to leak in. If an error happens, we could have like a full security exploit. They even give you some other neat tools. Like, let's say I've changed what's running, but I haven't saved it to disk yet, and I notice a problem. I can actually undo my changes. If you do iptables-f, that flushes the rules in RAM, and it reloads the rules from the command, from the configuration file. So that /etc/sysconfig/iptables, it just reloads it into RAM. So if you have a temporary change you want to make, you could make the temporary change and then do whatever it is you're doing. And when you're done, you could just do iptables-f and it'll reload the rules and put them into RAM. So now when I do iptables-list, I can see those rules came in. And oh, actually, looks like mine is empty here, which is not a good sign. So let me make sure that my /etc/sysconfig/iptables command got populated. And it did get populated, but the rules didn't get attached. So I've encountered a problem on this. And if this happens, well, I've swapped out a lot of rules for another one. I might actually need to restart the service. So let me go ahead and do a systemctl restart iptables, which is not normally needed, but I just want to be on the safe side here. And I'll do that iptables --list one more time. And there they are. Now they're popping up and showing in there. So be careful with that. You always double check your rules to make sure they apply, because otherwise you can end up in a situation where no traffic is being allowed. And that would be bad.
Does everything have to be done with the iptables command?
It doesn't have to. I'm having to jump through some extra hoops here because I'm using that command. But it's recommended that you do use the iptables command, because if you have an error in your rule, it tells you there's an error. No harm, no foul, right? You just move on and that's it. But if we don't want to use iptables, we can actually go and directly edit the configuration file. But if you make an error in that file and you reload the service, the firewall could fail to load. And now you might be allowing all traffic in. You might think your system is secure, and then it turns out it's not because the iptable service is stopped. That would be bad, right? So a firewall failing open is really bad news. So using the iptables command makes sure that doesn't happen. But there are a lot of third-party programs, or even just older admins like me, because in the early days of iptables, we didn't have a simple command line. You actually had to edit the config file and restart iptables anytime you made a change. So if you're one of those people, you can still go and edit it. All I would do is use something like Vim or Nano or whatever and point at /etc/sysconfig/iptables, and there's your rules. So if I wanted to add in something new, maybe I want HTTPS to be in here as well, I could come in and just add that rule and specify that in here. I'm going to set D port to 443-J accept. So there we go. So now I'm allowing HTTPS traffic to come in, and I'll just save that file. And if I reload iptables, or in theory, if I do the -F to roll it back, then I should see that rule come in. And if I do an iptables -list, whoops, iptables with an S, there we go. I can see that HTTPS is now being cleared through the rule. And I did it without the iptables command. I just did it by modifying the configuration file. If you use a web-based management tool like cPanel or WebAdmin or something, they're directly editing the configuration file. They're not using the iptables command. And that's because it's programmatic. They know they're not going to make a mistake. But as a human, I make mistakes all the time. So I prefer to use the iptables command if I can.
Can we monitor what iptables is doing?
Sort of, yeah. So like if you want to see,
sort of. That's the answer I wanted. Kind of, Zach.
It's not like there's some kind of cool chart, like a speedometer that shows traffic being blocked or whatever.
Yeah.
There's third-party programs that do that.
Oh.
But inside of iptables, there are a few things we can do. For example, I kind of lied earlier when I said there were 3 actions we could take. I said there was accept, reject, and drop, right? There's actually a 4th action we can take, which is called log, but you don't use log by itself. So I don't really consider it its own action. What you can do is if you want to log traffic, you can create your rule that's accepting or rejecting or dropping. And then you can create a duplicate rule and set the action to log. And it'll log that traffic in addition to taking the action. So you can certainly do that. I usually don't, just because when you're talking about network traffic, it can generate a ton of data. Those log files can grow really fast. So I don't like to do that, but you can. It's just same rules that we've already written, just make the action set to log. There are a few other things, like we can look at statistics. Those are a little bit easier. If you run iptables dash VN capital L and dash dash line, when you run that command right there, that's going to show you statistics for your configuration lines. So my configuration comes up, and see right here, I can see my policy. It's set to accept, and 2,965 packets have passed through so far. Then I can see which amount of packets applied to each rule and how many bytes applied to each rule. This is a better way to get in and see, how my rule counts are applying, and whether or not they're actually working and doing what they're supposed to do. And this kind of summary is much easier to manage than a log statement. So that was iptables dash VN capital L dash dash line. And so that's going to bring it up just like that. If you want to see this in real time, I kind of cheat a little bit and use the watch command. So if you're trying to watch the firewall while it runs, do watch dash N 0.5. I'm telling it I'm going to run a command, and I want it to run twice a second or every half of a second. And then I'll say the command is going to be iptables dash VNL, like that, or capital L. When I run that, it's going to, whoops, I keep leaving the S off of iptables. So let me do that again. There we go. It's going to bring it up on the screen, and then it's going to update twice a second. So if you watch the accept values up here, see how they're slowly ticking up?
Yeah.
Right? It's actually changing. So this is kind of like a dashboard for my firewall.
Right.
And if web traffic is coming in, I'll start to see that in these accept ports, and what's coming in. If there's blocks and so on, we'll kind of see it as a live updating dashboard. So it is kind of a neat thing that you can do and lets you monitor what the firewall is doing.
It is very neat. Thank you, Don. Filtering traffic with iptables, another wonderful episode. And before we move on, it looks like you have something else you might want to say.
Yeah, Firewall D is largely the replacement for iptables, but iptables is still in use in a lot of places. And so, definitely learn both, be familiar with both. But behind the scenes, they are both using NetFilters. So NetFilters is kind of nice that we don't have to deal with it. Its configurations are hard. iptables and Firewall D do them for us. So, pick which one you're most comfortable with. Going forward, though, if you're deploying new systems, you probably don't want to use iptables. Eventually, it is going to go away. Firewall D is the replacement, so keep that in mind.
Great advice and more good advice. Watch every episode of CompTIA Linux Plus. You are going to be so glad you did. It's going to help you now and in the future. And keep studying, keep learning. We're always learning, aren't we? Make sure you take advantage of the supplementary information in our course library. It's there to do one thing, help you be even more successful. So check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again very soon.
Thank you for watching IT Pro TV.